This is example 7 from lesson R.2. We're going to add or subtract some of these radicals. In part A, you will notice that all of the radicals are the same. We have the same index of 3, and we have the same radicand, the stuff that's underneath the radical, of 5w. If this is the case, then we can actually treat these as a variable and just add or subtract the coefficients. So -4 plus 9, that's going to give me a positive 5. And then 5 minus 11 is going to give me a -6. And then we'll just bring the radical and its index over here as part of my answer. And now this has been simplified. If we take a look at B, though, I do have the same index. They're both 2, but the radicand, they are not the same. But sometimes we can simplify them and make them look the same. So keep in mind that if they're unsimplified, you have to simplify them because you may be able to combine them. If they're simplified and they don't look alike, you can't add them. It's like adding x plus y. You can't combine those. And so your answer or your simplified form of x plus y is just x plus y. It's the same thing with radicals. All right, so what we're going to have to do is we're going to come over here to the side. I'm going to look at 75. I'm going to break that down. And I know that 75 cents is actually 3/4. So this is 3 times 25. And 25 is actually 5 times 5. And since this is a square root, my index is a 2, which means I'm looking for pairs, and I actually have a pair of 5s. So I can bring that 5 out in front. Now, the C, I notice there's only one of them. This one's going to have to stay under the radical. This 3 is going to have to stay underneath the radical because there's not another 3 up here. Now let's look at our d to the 4th. Remember, I'm looking for pairs. Here's a pair of d's. Here's another pair of d's. So I can bring a d out front, and I'm going to put a 2 exponent on it because I had 2 pairs of d's. And then I'm going to rebuild my radical here with the 3 and the c right here. And so this radical simplifies into 5d squared times the square root of 3c. All right, now the other one, we're going to simplify this one in the same way, but when we're finished, we don't want to forget we're supposed to multiply this by the 6d that's already out in front. So I'm just going to put a parenthesis here. We're going to simplify this, and then in my next step, I'm going to multiply that 6d there. All right, so 27 is 3 times 9, and 9 is actually 3 times 3. Okay, since this is a square root, I need pairs. I have a pair of 3s, so I know I can bring that out in the front. This 3, though, is going to have to stay under the radical because there's not another 3 to go with it. I've only got one c, so that's going to have to stay underneath the radical, and then I have d squared. This is a pair, so I can actually bring a d out in front, and I can put a 1 exponent on there because there was one pair of them. Now let's build our radical. I have left inside this 3 and this c right here, and that's it. All right, so in my next step, when I go to multiply 6d times my radical expression right here, I'm only going to multiply times my outside numbers. This 6d does not distribute into the radical, and that's because it's not underneath the radical. All right, so the first one's not going to change. We're going to have 5d squared times the square root of 3c. All right, now 6 times 3, this is 18. D times d is going to give me d to the 2nd. And then the radical expression is just going to come down here and be part of my solution there. And now I can see I'm in the same situation I was up in here. I have the same index. I have the same radicand. Now I can just add my coefficients there. So 5 plus 18 is going to give me 23. And that's 23 of those d squareds. Okay, don't add those together and give me d to the 4th. D to the 2nd times d to the 2nd is d to the 4th. But I have 5d to the seconds over here and 18d to the seconds over there. So altogether I have 23d to the seconds. And don't forget to bring down the square root of 3c there. And now this one has been simplified.